Thanks, Priya. Thanks, Priya. Right, so what this does is, now, it's important to remember what this does, okay? Now, this only gets the sum for each employee. So I'll do an example of that. So I'm going to go to my annotation. Now, so let's say we have one employee that weighs 3 animals. Okay, employee A. Employee B weighs 2 animals. 3 weights is 10, 20, and 30. So the sum for that is going to be 50. Let's say B employee weighs 2 animals, 15 and 45. That's going to be 60. Let's say employee C weighs 3 animals. The first animal is 30. The second animal is 45. The last animal is 25. Okay, which gives us a total of 100. Okay, so that's what sum produces. All right, so that's employee A weighs animals total weight of 50. Employee 2 weighs animals total weight 60. Employee 3 weighs total animal weight 100. All right, so what I need to do is that I need to add up each one of those. So 50 plus 60 is 210. Yes? Now, so it's important to show you here that this does not do that. This only adds up the weight for each employee. It doesn't add up the total weight. Everyone with me so far, yes? Right. So that means that we need to do some sort of something else that knows that each one of these guys, so this runs for an employee, okay? An employee who has 3 animals or less. And this gets the sum of what they print out, okay? Now, it doesn't add them all up. So that means you're going to have to put in the adding up part in the else. Now, this is not the recursive part, all right? The recursive part is the part that keeps going down. So it's the exact same as the other one. You start off with 10 and you split it up into 2. And then you further split those 2 up into 2. So you end up with 4. Okay? You've 7 created and you end up with 4 that are actually going to be used. The first 3 are not used. Same process happens again. You have one generation that could weigh 10 animals. The second generation of 2 managers could weigh 5 animals each. The third generation of 4 animals, or 4 employees, can weigh, one of them can weigh, 2 of them can weigh 3 animals, 2 of them can weigh 3 animals. Okay? Now, so the else part, this is the recursive part. So we're down here. Now, else. Return null here at the bottom. Now, so just like before, we want to get the middle is equal to start plus bracket end minus start divided by 2. Can everyone see this now? Can Igor, Priya, can you see it?
Yeah.
Yeah. Make sure you shout big in if that happens. Right. Now, and again, I'm going to go this line. Let's have it here. So start, middle is middle, end is end. And if we see it up to that point, it runs exactly the same as the other program. All right, now. So now instead of using invoke all and having two employees created that way, we can't use that here, okay? Because invoke all returns nothing, returns void, right? Invoke all returns void. So we need something that's going to return some sort of value, all right? Now we're still going to be creating two employees in this case. We're just creating them a different way, all right? So put in here. We can't use invoke all as this does not return any value. And even, so this is a recursive method, but each time it calls itself, it still has to return a double, okay? Invoke all doesn't return anything. So you can't use invoke all, okay? To return the value. We are still creating twice the amount of employees as the previous generation. Now, what's that? First gen, 1 employee. Second gen, 2 employees. Third gen, 4 employees. Okay, so we're still creating twice the amount of employees as the previous. However, we use forking and joining for this instead. Now, what we're actually going to do now, so recursive task calls a compute method. All right. Now, what we do is inside here, we create another recursive task. So what does that do? That calls the compute method again. So if I do this, recursive task double, I'm going to call it other task. I call this other task is equal to new employee. And instead of putting the new employees in the invoke all, we do one here, which is going to be waits, start, middle. Now,
contact extension 1873. That's General Assistant contact extension of 1873. Thank you.
Now, it's at this point we create another thread. Okay. So we're going to have a thread per employee. Yes? Yeah? Nice. So we're going to have a thread per employee. So this creates another thread. Because the previous thread, this is the guy here, I go other task.fork. That means we create another thread. Okay, we create another thread. Now, what do we do with another thread? Let's put it in here. We go return. So this is where we create the second employee. So we're creating 2 employees. We're just not using invoke all. We're using another recursive task to create the first employee, and we're using the return statement to create the second employee. All right, so we go new employee, and it's weights, it's middle, and it's end. Now, it's going to call the compute method. Now, an other task dot join. Now, what that's going to do is that at the end now. So if our employee is actually weighing animals, that employee is going to, so that compute method is going to return the sum of, so let's say this, say employee does 3 weights. That guy is going to return the sum of those 3 weights. Okay? And it's not going to go on to the next employee until it has this done. Okay? So this one here is on one thread. We create another thread. Okay? So we're here in another thread. Now, it's not going to go on to the next task, not going to go on to the next creation of the next employee until it has all of that guy done. Okay? Until it is calculated. All right? So instead of using invoke all to create these 2 employees, we create the 2 employees by a combination of forking and joining. Now, you have to put in a join here. I show you it with a join, and I show you it without a join. Okay? So, I want to get the sum. Just going to leave that for here. So, this creates our second employee. So instead of creating 2 employees with invoke all, we are creating 2 employees with a combination of fork and join. Okay, now what the join does. Your program will not progress onto the next employee calculation of total weight for employee until the previous one has been completed. Okay, because now if you didn't have another task.join, it could go calculating the weight of the second lead before the first lead is even finished, and it only takes a temporary. So let's say it could do something like this. Okay, if it didn't have the join. Now, it's been told that employee A weighs 3 animals. Employee B weighs 2 animals. Employee C weighs 3 animals. Employee D weighs 3 animals. 2 animals. Now, we want to ensure that all of A is done before it progresses on to B. Okay, because if you didn't, it might have finished calculating up B and it might be only halfway through A. Okay, so let's say the weights is 10, 20, and 30. It might have done B, and it adds up whatever's in A at that moment in time. It might only have got as far as 10. So it's adding 10 onto it instead of 50. That's why you need to put in the join. Okay? It waits until the previous task is finished. All right? Now, I trust I don't have to go explaining. So you can see here, weights, start, middle. Okay, here, weights, middle, end. It's the exact same as the invoke all. If you look at the invoke all for manager. So invoke all, we have weight, start, middle. We have weights, middle, end. You have 2 employees are still created. So one generation was 1. The next generation has got 2 employees. The next generation after that has 4 employees. The next generation after that would have 8. The next generation after that would have 16, and so on and so forth. Okay, we only got as far as the 3rd generation here. So we end up with 4 employees. Okay, 7 created, 4 are used to weigh the animals. Okay, now, so I'm going to go back here. So I'm going to say here, total amount weighed is sum. Okay, and I want to see how many employees are created. There are counter created and there are employee.emp counter used. Okay. Oops, sorry, I haven't ran it. So I'm just going to go to main here. It's EX6. Right, so we have 4 employees used. So we have 1 employee has weighed 218. Another employee, sorry, 65, 218, 107, 176. Now, if I added those 4 up, I will get 566. Okay. Now, if I added all of these weights up as well, I'm not going to do it. It would also come to 566. Okay. I don't know what else to say. That's it. Okay. So the only extra thing in here is instead of using invoke all, we're using other tasking and forking. We have to be careful with saying that. Okay. Now, if I didn't put in a fork, so I'll take out the fork. Or the join, sorry. Take out the join. The total weight is 120. What it's actually getting there is the total, that's just the weight for the last employee. Okay. See what happens there? 120. I think that's what you always get every time you run it. So let's have a look again. Yeah. See, this employee is weighed 145. It's 145 because I haven't said to add it up. So all it's doing is it's getting the last employee's total. So if you put in other task.join, that will add up all of the totals. Okay. So this will add up all of the totals from each employee. If we did not include other task join, it would only return the total weighed by the last employee. That's all. Okay. Any questions on that? So now let me tell you this. That is way easier than using, there's things called priority threads, and oh Jesus, were really, really difficult to use. You determined one thread was more important than another thread. You don't need to do that anymore. All right. Now, if you try to create threads the old way here, you can't. All right. It only works with JRE 7, I think, as far as I know. From JRE 8 onwards, you can only create threads by using this executor service. I'll just show you the old way of creating threads. Now, here they are. So first thing you need to do, you need to create a class that implements runnable. Then that's how you create threads the old way. Thread T2 is equal to new thread my threads. It's just, they're just, and you have to start it. And it's nigh impossible to stop it. You can only create threads by, so thread T1, you have to have an object that implements the runnable interface. All right. I'm not going to even bother putting the code up. See, there it is. That's grid priority. That's all about, that's priority threads. What you're doing there is you're saying this thread is going to get priority over all other threads, which it's just not easy to use. Okay. So executor service is far easier than this shit. Okay. But now we have threads done. Just the last section, it just details the various issues you can have with threads. Now, a lot of these issues are minimized by using these executor services and these forking and joinings and these fork join pools or the thread pools, whatever. Okay. A lot of these issues are minimized, but they're not eliminated. Okay. So now, this is just a section where we identify what sort of issues you can have. So this is going to be, so I'm going to save that. I'm going to export that.